This videotape deals with addition and subtraction of radical expressions. Algebraic expressions can often be simplified by adding or subtracting terms that contain the same radical. The procedure is very similar to that of combining like terms in polynomials. Okay, and the technique, the key to the process is the distributive law, just like it was in combining like terms when you had polynomial expressions. The distributive law, a plus b times c, is ac plus bc. This is the key to the process. A plus b times c. I've written the c on the right here. We're going to still distribute c through the parentheses. Most of the time you see the quantity to be distributed on the left of the parentheses, but it can also be written on the right. AC plus BC. You're distributing the c through the parentheses. If you remember when you wanted to combine like terms 5x plus 3x, the key to the process was to write this as 5 plus 3 times x. This is 5x plus 3x. And then add 5 plus 3 to get 8x. Of course, after a while you got good at it and you left out the middle term, the middle expression here, and we went right from 5x plus 3x to 8x. The idea is combining like terms. These were like terms. They had the same variable part. You just combine their numerical coefficients and you got the 8x. Now let's say we're dealing with 5 times the square root of 2 plus 3 times the square root of 2. Okay, we can rewrite this as 5 plus 3 times the square root of 2, and that will give us 8 times the square root of 2. And this is how we're going to add, okay, terms that have the same radical. We will combine the quantities outside of the radical, the 5 plus 3 giving us 8, the square root of 2. Okay, let's look at another example. 7 times the square root of x plus 3 times the square root of y minus 5 times the square root of x minus 4 times the square root of y. Now we have two different types of radicals here. We have the square root of x in the first and the third terms, and the square root of y in the second and the fourth terms. We can combine the first and the third terms and also the second and the fourth. Okay, we have 7 times the square root of x minus 5 times the square root of x. We can write that as 7 minus 5 times the square root of x. This covers the first and the third terms. 7 times the square root of x minus 5 times the square root of x. Now the second and the fourth, we have 3 times the square root of y, 3 times the square root of y minus 4 times the square root of y. We can write that as 3 minus 4 times the square root of y. This gives you 7 the square root of x minus 5 the square root of x plus 3 the square root of y minus 4 the square root of y. Okay, now the two terms with the square root of x is 7 the square root of x minus 5 the square root of x gives us 2 times the square root of x, and 3 minus 4 the square root of y gives you minus 1 times the square root of y. Generally, however, we leave out the 1, and we would write this answer as just 2 times the square root of x minus the square root of y. Okay, from here we would go right to there. If you want to leave the 1 in, fine. 3 minus 4, that's minus 1. If not, you can leave it out. But when you leave it out, remember there is a 1 implied. Okay, now let's look at something like this. 4 times the square root of 18 minus 5 times the square root of 8. And if you look at this very quickly, you might say, well, you can't combine these. These are different radicals and different quantities under the radical sign. You have the square root of 18, you got the square root of 8. It's like the problem that we had before when they both had the square root of 2 or both had the square root of x. Okay, now that's true on the surface, but the thing is that you can't really make a decision like that until you've put the radicals into simplest radical form. Okay, if you are not sure of what I mean by simplest radical form, I would suggest that you look at the preceding videotape. Okay, in simplest radical form, we try to put the radicals into a very simple form where we take out as much as we can from under the radical sign. Okay, and when we do that, it'll turn out that these two radicals really have a lot in common. Let's work this out. To begin with, I will write the square root of 18 as the square root of 9 times 2. 18 is 9 times 2. I'm looking for perfect square factors. And then I will write the square root of 8 as the square root of 4 times 2. Both cases I was looking for perfect square factors. 9 was a perfect square factor of 18, and 4 was a perfect square factor of 8. Then using properties of radicals, I can take the square root of a product and write it as a product of the square roots of the factors. I can make this 4 times the square root of 9 times the square root of 2 minus 5. Instead of the square root of 4 times 2, I can make it the square root of 4 times the square root of 2. Okay, now the square root of 9, 9 is a perfect square. The square root of 9 is just 3. So we have 4 times 3 times the square root of 2 minus 5. The square root of 4, that's just 2 times the square root of 2. And we have 12 the square root of 2 minus 10 the square root of 2. We now have both radicals that we started with in simplest radical form. And in this form, it is easy to see that they do involve the same radical. They both involve the square root of 2. We have 12 times the square root of 2 minus 10 times the square root of 2. Two terms involving the same radical. Okay, so we're going to combine what's outside of the radical sign. 12 the square root of 2 minus 10 the square root of 2. 12 minus 10, or 2 times the square root of 2. But it wasn't until you put them into simplest radical form, which is at this point here, that you could recognize the fact that they did involve the same radical. Okay, so the key to adding and subtracting radical expressions would be first to put all the radicals into simplest radical form, and then those terms that involve the same radical can be combined. Let's try an example that involves variables as well as constants. 3 times the square root of 20x plus the square root of 45x. Okay, at first glance, these radicals are not the same, but we're going to put them into simplest radical form, and then we will notice that there are similarities. Okay, the square root of 20x will be rewritten as 4 times the square root of 4 times 5x, looking for perfect square factor of 20x, which is 4, and the square root of 45x will be rewritten as 9 times 5x. We're taking perfect square factors out of 20x and out of 45x. In this case, we have 4, and here we have 9. You will notice, by the way, that what is left over in each case is the same, 5x. Okay, so we suspect that we will be able to combine these later on. Now, we make use of the fact that the square root of a product is the product of the square roots of the factors. So this can be written as, instead of the square root of 4 times 5x, it's the square root of 4 times the square root of 5x. And here, the square root of 9 times 5x is the square root of 9 times the square root of 5x. And just want to remind you that this can only be done for multiplication and division, not for addition and subtraction. Okay, you cannot make 20x 4x plus 16x and work like that. You have to work with perfect square factors, things which multiply to give you 20, not which add to give you 20. Okay, now the square root of 4, of course, is 2. So we get 3 times 2 times the square root of 5x. The square root of 9, that's 3. So we get 3 times the square root of 5x. And we have 6 times the square root of 5x plus 3 times the square root of 5x. We now have these radicals in simplest radical form. We notice that the quantity under the radical sign is the same. We can combine these terms. 6 the square root of 5x plus 3 the square root of 5x gives us 9 the square root of 5x. And that is the answer. Okay, let's try another example. The square root of 6x cubed minus x times the square root of 24x. Okay, it's been mentioned before, but I just want to go over it again. In all of our work with radicals here, we're going to assume that all variables are positive real numbers. Okay, if you want to try this problem on your own, you can shut off the videotape machine and turn it back on when you've finished. Okay, the square root of 6x cubed. We would like to put, of course, both of these terms into simplest radical form, and then we're going to try to combine. So the square root of 6x cubed, let's see, we want a perfect square factor of 6x cubed. The best we can do in this case would be x squared. X squared is the largest perfect square factor of 6x cubed. 6 has no perfect square factors other than 1, and we're not interested in that. X squared is the best we can do on the x part. Minus x times, now for 24x, x we can't do anything with, but for 24 we can pull out at least a 4, giving us 4 times 6x. The square root of a product is the product of the square roots of the factors. So we'll write this as the square root of x squared times the square root of 6x. And similarly here, we will write this as the square root of 4 times the square root of 6x. Now the square root of x squared, x is a positive number. The square root of x squared is just x times the square root of 6x here minus, now, the square root of 4 is 2. We have x times 2, or 2x, the square root of 6x. Okay, we now have them in simplest radical form. We want to combine the quantities that are outside of the radical. We have here x, which is really 1x minus 2x. 1x minus 2x gives you minus 1x times the square root of 6x. And we would just write that as minus x times the square root of 6x. Okay, we have x take away 2x. 1x take away 2x leaves us with minus 1x. Now we have times this radical, so minus x times the square root of 6x. Okay, let's try another example. The square root of 50 x cubed y to the 4th plus xy times the square root of 32xy squared. Once again, if you want to try this on your own, you can shut the machine off. Now we're looking for perfect square factors of 50x cubed y to the 4th. Okay, first we'll worry about 50. The largest perfect square factor of 50 is 25. Then for the x cubed, I take out x squared, and for y to the 4th, the whole thing can be used, leaving us with here 2x. This gives you 50 x cubed y to the 4th. On the variables, you always take out the largest even power of the variable. Okay, for under a square root sign, looking for the perfect square factors, you can always take out the largest even power of the variable. Okay, the square root of a product is the product of the square roots of the factors. We will break this up, give us the square root of 25 x squared y to the 4th under the radical times the square root of 2x. Here we have xy outside of the radical. We'll make this the square root of 16y squared times the square root of 2x. Now, 25x squared y to the 4th is a perfect square. The square root of 25 is 5. The square root of x squared is just x. The square root of y to the 4th is y squared. Okay, you take the square root of the constant and you have the powers on the variable. 5xy squared times the square root of 2x plus xy. Okay, the square root of 16, that gives us 4. The square root of y squared, that's y, times the square root of 2x. This gives us 5xy squared, the square root of 2x, plus 4xy squared, the square root of 2x. Up until this point, we were just putting these radicals into simplest radical form. We now notice that they do involve exactly the same radical in simplest form, namely the square root of 2x. We have 5xy squared times that radical plus 4xy squared times the radical. So we combine 5xy squared plus 4xy squared to get 9xy squared times the radical, which is the square root of 2x. Final answer, 9xy squared times the square root of 2x. Okay, let's try one more example. And this example, once again, involves radicals that have to be put into simplest form. But the second radical in the expression here involves a fraction under the radical sign. And that's going to be handled by rationalizing the denominator. The square root of 12x will be handled just the way we handled all the other examples today. Okay, we want to combine this expression if possible. Before we can make a decision, we have to put the radicals into simplest form. If we put the radicals into simplest form, then if they have the same quantity under the radical sign, we will be able to combine. But we won't know that at this point. Okay, on the square root of 12x, we're looking for a perfect square factor of 12x, and we notice that we can have 4 is the largest perfect square factor, so we have 4 times 3x. Minus, now, this is not in simplest radical form because there is a fraction under the radical. So we make use of the property of radicals that says the square root of a fraction is the square root of the numerator over the square root of the denominator. Now, the square root of a product, we can break it up into the product of the square roots of the factors. The square root of 4 times the square root of 3x minus, now the square root of x over the square root of 3 is still not in simplest radical form because although we don't have a fraction under the radical, we now have a radical in the denominator. Okay, and the way to handle this is to rationalize the denominator, that is to multiply numerator and the denominator by the radical in the denominator, namely the square root of 3. We are multiplying numerator and denominator of a fraction by the same quantity. We will get, therefore, an equivalent fraction. Okay? Back over here on the first term, we have the square root of 4, which is 2. This gives us 2 times the square root of 3x minus, now, to multiply two fractions, we multiply the tops and we divide by the product of the bottoms. Okay? When you multiply the square root of x times the square root of 3, you get the square root of 3x. Okay, we usually use this the other way. For example, the square root of 4 times 3x, we made it the square root of 4 times the square root of 3x. We broke it up. But you can also use it to put things back together again. The square root of x times the square root of 3 is the square root of 3x. The square root of 3 times the square root of 3 is just 3. The square root of a number times the square root of the same number is just the number itself. It squares out. You just get the number. Okay, so we have 2 times the square root of 3x minus the square root of 3x over 3. We have two terms involving the same radical, namely the square root of 3x. The question is, how do we combine them? Well, the problem here is that we have fractions. This 2 the square root of 3x is really 2 the square root of 3x over 1. And this is really minus 1 the square root of 3x over 3. So how do you add or subtract two fractions? Well, you have to have them first. Well, you have to first give them the same denominator. Okay, we use the fundamental principle of fractions to multiply numerator and denominator of fractions, okay, by the same quantity to get equivalent fractions. The idea being we want two fractions with the same denominator. When we have the same denominator, then we just combine the numerators. Okay, now the lowest common denominator, we have a 1 and a 3. The lowest common denominator is 3. We don't have to do anything to the second fraction, but to the first one, we'll have to multiply top and bottom by 3. Let's see where we are. Let me rewrite what we have so far. We have 2 the square root of 3x over 1 minus the square root of 3x over 3. Okay, the second fraction we'll leave alone, but the first fraction we will multiply top and bottom by 3. It's legitimate to do that because we are multiplying top and bottom by the same quantity. If we do that, 2 to the square root of 3x times 3 gives us 6 to the square root of 3x. 1 times 3 gives us 3, minus now the square root of 3x over 3. So we have 6 to the square root of 3x over 3 minus 1 to the square root of 3x over 3. They have the same denominators. We combine the numerators. Okay, we're going to get 6 to the square root of 3x minus 1 to the square root of 3x all over 3. Once they have the same denominators, you just combine numerators. 6 to the square root of 3x minus 1 to the square root of 3x gives you 5 to the square root of 3x, and this is all over 3. And that is the answer to the problem, and this is the end of the tape.